Hello everyone, welcome to Chemical Hub. And so today we are going to discuss a new topic, that is temperature lapse rates and stability, which is covered under meteorological aspects of air pollution. So let's begin. First, let us understand about why understanding of natural processes related to dispersion is essential. As the pollutants undergo various changes till they reach their receptors, so we need to understand about how much will they disperse. Effective dispersion of pollutants depends on stability of atmosphere and the turbulence present. Hence, stability depends on rate of change of ambient temperature with altitude. This rate of change of ambient temperature with altitude is known as lapse rate that we will discuss. So what is lapse rate? The change in temperature with increase in height is known as lapse rate. This change can be increasing as well as decreasing, which depends on the layers of atmosphere. Here we are going to discuss about the decrease in temperature with increase in height in the troposphere layer of atmosphere. Now let us see about ELR versus ALR. What is the difference between both of them? ELR means environmental lapse rate. When air rises in the atmosphere with increase in height, its temperature decreases. Hence, the rate at which the temperature of air decreases with increase in height is called ELR. ELR as given is 6.5 degrees Celsius per kilometer, whereas adiabatic lapse rate ALR is when pollutant rises in atmosphere. With increase in height, its temperature decreases, but there is no exchange of heat. The rate at which the temperature of pollutant decreases with increase in height is called ALR. Sorry, this is a small mistake. Is called ALR. ALR equal to 6 degrees Celsius per kilometer for wet process, that is for the saturated air, and is 9.8 degrees Celsius per kilometer for dry process, that is for the dry air. Now let us see about the conditions when ELR is greater than ALR, ELR is less than ALR, and when ELR is equal to ALR. The super-adiabatic or unstable environment. It occurs when ELR is greater than ALR. As we can see here from the isothermal reference, if we take ELR is greater as compared to ALR. So in this condition, the rising particle of pollutant cooling at adiabatic lapse rate will be warmer and less dense than surrounding environment. Hence, it becomes more buoyant and will continue to move upwards. Air from different altitudes will mix thoroughly and will rapidly disperse effluents throughout atmosphere. Thus, it will help in preventing the pollution. Here we can see that the temperature of pollutant is greater than the temperature of air. Hence, the pollutant is warmer as compared to the air, as we discussed. Sub-Adiabatic or stable environment, where ELR is less than ALR. Here, the rising parcel of pollutant becomes cooler and is more dense than its surroundings and falls back to its original position. Hence, under such stable condition, there is a little mixing and pollutant disperse very slowly. The levels can build up rapidly in the environment. Here we see the temperature of air is greater than the temperature of pollutant. As we have seen, the pollutant is cooler as compared to air. Next comes the neutral environment, where ELR is equal to ALR. This is the reference to a neutrally stable atmosphere. The rising parcel of pollutant will have the same pressure, temperature and density as of the surroundings and would experience no buoyant force. Here the pollutants will stay as they were and they will not displace. Here we can see both ELR and ALR are the same, that is temperature of air equals temperature of pollutant at a certain height, and hence it is neutrally stable atmosphere. In the next video, we will discuss about another phenomena, that is inversion. I hope you liked this video. Thank you for watching. Do like, share and subscribe my channel.